Alright, so in this video we're going to be just introducing parabolas and some of the terms around it. So what is a parabola? A parabola is a curve that has a line of symmetry. So here we can see we've got this sort of curve, and if I was to put a mirror smack bang in the middle, we could see that sort of symmetry going on. So to help us out with parabolas, there's some key things that we need to make sure that we're aware of term-wise. So to start off with, here at the very base of my x-axis, we have these 2 points here. And we call these parts here the roots. So specifically, the roots is where the graph crosses the x-axis. And the important thing that we must always keep in mind, and this is going to be crucial in the next little bit of this topic, is that at the roots, y is always equal to 0. And we'll come back to why we need to keep that in mind. So then the next thing we need to think about is in between the roots. Like I said earlier, if I was to put in a mirror, and I could put mirror all the way up here, that would show that there's this sort of symmetry, and in fact we call this our axes of symmetry. And so the axis of symmetry the important thing to remember about that is that it is an equation. So for our equation, it is always going to be x equals, and then it's whatever value the x coordinate is in between our roots. So we find our axis of symmetry. We find it by finding the x value in between the roots. And then there's one other key thing that is new to Nat 5, and it is this point here at the very bottom, at least at the very bottom of this graph anyway. And we call this the turning point. So our turning point is the other thing, and to find it, our x value is the same as the axis of symmetry. And so in order to find the y value, we substitute the x value into the equation that you are given. And then one last thing, we would have come across it before, but at that point there, that is our y-intercept. And just to help us find out what the y-intercept is, we must always remember that x equals 0, always. So those are our key aspects that are used for introducing for parabolas. So let's take a look at a couple of examples where we have to identify these elements. So in this first one, we're being asked to state the roots, axis symmetry, turning point, and y-intercept for the following. So the first thing there, we can see that our roots have been labelled for us. So my roots roots are going to be -5, 0 and 3, 0. So then our axis of symmetry, and we'll probably just write axes for our next question. Axis of symmetry, I want to find the x value that is in between. Oh, I just realised that should be -3 for the other root. I want to find the value that is in between -5 and -3. If need be, if you're struggling to think how to find the value in the middle, add them up and then divide it by 2. So -3 add to -5 is -8. Divided by 2 gives me -4. So my axis of symmetry is going to be x equals -4. Then my turning point, I'm just going to write TP for that. My turning point, I've got to take that x equals -4, and then I'm going to substitute it into the equation it is given us here to find y. So I'm going to have y equals -4 squared plus 8 times -4 plus 15. So it's going to be a positive 16, because remember negative times negative makes a positive. Then -32 plus 15. And so then that will just be -1. And so then my turning point, my x coordinate is -4 and my y coordinate is -1. And then the last little detail, my y-intercept. And remember, x always equals 0. So to find that y coordinate, substitute that 0 in. So y equals 15. So my y-intercept, if I was to write it as a coordinates, would be 0, 15. And you may have to draw these details back onto our graph. So if I was to draw my axis of symmetry, drawing it up there, and writing x equals -4, putting in that point down the bottom and putting in my coordinates of -4, -1, and then drawing in my y-intercept at that 15 mark. Okay, so one more question just to look at. So this one here, asking the same detail. Now this looks a little bit different. This time it is upside down. The reason why is because we have a negative x squared. That makes it go upside down like that. But the idea is still the same. So to begin with, my roots, I have that -2, then it'll be 0, and 6, 0. My axis of symmetry, find the number in the middle, and divide by 2. So my axis of symmetry is x equals 2. Then my turning point, so taking that value of 2, I've got to substitute that into my formula. Now here we have that f of x. Remember that f of x is essentially a new kind of y for a lot of our graphs, so it still works. So I'm going to substitute that 2 in. So I've got -2 squared plus 4 times the 2 plus 12. So it's going to be -4 plus 8 plus 12, which is going to just give me 16. So my turning point is going to be 2, 16. And then the last detail, the y-intercept. So x is going to equal 0. So it's just going to be 12. So the y-intercept is going to be 0, 12. And then just drawing it all back in. So my axis of symmetry comes up the center there. And that's x equals 2. My turning point is that to 16, and the y-intercept is there at 12. Now, for all these parabolas, us finding out the axes, the turning point, the y-intercept have all been made possible because we've been given these roots. So those roots have been given to us on the graph. But what if all I had as my information was this equation here? We need to now figure out, how can I find out my roots from just the equation? Because once I know my roots, then I can find out every other element of my graph. And that's what we're going to get into in the next video. I hope this one was all right. Let me know if you have any questions.